Good morning, guys. Let's continue chapter 4, which is about the force system resultant. Now, as we said earlier, the moment is a vector and its magnitude is equal to the force times d. Now, what is d? D is the perpendicular distance from the force to the point of rotation. Now, since the moment is a vector, so like the force system, the moment can have a resultant. So the moment system can have a resultant moment. So what is resultant moment? A resultant moment is the system of all the moments of all the forces that cause rotation. So as for the forces system, the moment system can also has a resultant, which is the sum of all the moments caused by all the forces, of course, that can do a rotation. Which means, guys, the sum of moment is equal to m resultant. As you can see in the slide 4, which is about the resultant moment, a moment resultant is the algebraic sum of the moments of all the forces, of course, causing a rotation around a point O. Now let's take the system here. In this system, I have three forces, F1, F2, and F3. And I have the distance, the perpendicular distance from each force to the point O. The question is to find the resultant moment around O. Of course, guys, this is a 2D problem, although the moment is a vector that belongs to the third plane, which is here. If this is x, y, then the moment will be, of course, in z. It could be positive or negative z. Now, since this is a 2D plane, I can find the direction of the moment without using my right hand rule. How? I will define two directions. The first one is called the clockwise direction. A clockwise direction, from its name, is the direction of the clock. So this is the direction of the clock. I can have an opposite direction, which is called the counterclockwise direction. So in 2D, guys, I can solve the problem without using the right hand rule. It is only by using these two directions. So I should find if my moment is in the clockwise direction or it is in the counterclockwise direction. I can indicate this. So I can say the resultant moment is equal to this value in the clockwise direction. So this is enough because here I'm indicating the magnitude of my force and its direction, which is enough for any vector. Now let's solve this problem by first finding the moment for each force. So I will start here by M1. What is M1? Of course, M1 is F1 times D1, since as you can see here, D1 is given as the perpendicular distance from the force F1 to O. I will keep some space here to see what is the sign of the moment later on. Now what is M2? M2 is also equal to F2 times D2, and M3 is equal to F3 times D3. Okay guys, now what about the direction of M1, M2 and M3? In order to know if the direction of this force is in clockwise or in counterclockwise, I advise you guys to draw the circle of rotation of F1 around O, F2 around O, and F3 around O, and you can predict the direction of the moment if it is in counterclockwise direction or in clockwise direction. So let's draw it. So basically guys, this is the circle of rotation of F1 around O guys. So you should draw it around O, because I can draw another circle here, but the circle of rotation is not around O. So I should draw the circle of rotation achieved by F1 around O, and this of course will be the rotation because this is F1. So what do you think? What is the direction of this circle of rotation? As you can see guys, F1 has the direction of counterclockwise. Did you see the direction here? Which means that F1 is in counterclockwise direction. Now what about F2? F2 is doing a rotation in a clockwise direction. So as you can see, F2 is doing a rotation in the same direction of the circle here, that is the clockwise direction. So M2 is in clockwise direction. Now, F3 is doing a rotation in what? If I continue the circle, I will have the same direction as what? As the first moment, which is the counterclockwise direction. So it is in counterclockwise direction. If I need to find the resultant moment MR will be equal to the sum of M1, M2, and M3. So this is M resultant. How can I sum them without knowing their sign? So basically guys, I should assume a positive direction. I can assume that the counterclockwise is my positive direction. However, I should indicate this at the very beginning. So I should say here, for example, assume that the counterclockwise is my positive direction. And then guys, here I can say that M resultant will be equal to what? It will be equal to plus M1. So M1 is now in the positive direction. M2 is in the negative direction since M2 is in the clockwise. And M3 will be in the negative direction. So MR will be equal to F1 times D1 minus F2 times d2, sorry, this is in the positive direction, plus f3 times d3. And this is basically, this will give me a value, and this value is in counterclockwise direction. Another method is to use the right hand rule. Even if this is a 2D problem, I can use it because the right hand rule is valid for all the cases. So if I go here, guys, and I need to apply the right hand rule, I know that this is x and this is y, which means that z is directed towards me. So the positive z is directed towards my face, towards me. The negative z is directed towards you. Okay, so let's do this. F1 is doing a rotation where the direction of the moment is towards me, which means M1 is in the positive z. So I can say this. Another method, so this is method 2. M1 is in positive z. Now what about M2? This is F2. F2 is going towards you, which means that M2 is in negative z. And finally, what about F3? F3 is doing this rotation, which means it is in positive z because the moment is towards me. So M3 is in positive z. Therefore, guys, M resultant in the positive z is equal to plus M1 minus M2 plus M3, or plus F1 d1 minus F2 d2 plus F3 d3. I know now that you have a question, and the question is, what if I assume that the clockwise direction is the positive direction? Yes, you can assume this. You can assume here that the clockwise direction is the positive direction, and in this case, M resultant will be equal to minus F1 d1 plus F2 d2 minus F3 d3 in clockwise. So you are asking yourself now that if I'm assuming that the clockwise direction is the positive one, then I will have the opposite answer than this one, then this M resultant. Basically, no. If you are assuming that M resultant is in the clockwise direction, you should say this, plus F2 d2 minus F3 d3. This is in clockwise direction. And basically, guys, the clockwise direction is in the negative z, which means this M resultant is in negative z. So if you do the comparison here, this M resultant here is in the positive z. So of course, the opposite of this M resultant will be in the negative z. So even if you assume that your clockwise direction is the positive one, so I can assume that my positive direction is the clockwise, you will have the same answer as the 3D case using your right hand rule. This is the end of this part. I will continue later on to solve the problems of the first part of this chapter. Thank you.